Hello everyone, I'm Nehal. So today I'm going to solve the Fastpaper Mock Championship 2026 paper 2 of AS level computer science. So let's start. I hope your mocks went well and I really hope this video helps out in clearing your confusion if you have any. So let's begin. Alright, before we start, I will just tell you something. Basically, this paper was a bit harder than the past papers. So even if you couldn't answer every questions, it's fine because 80% or 85% here means a 90% in your real exam. All right, because the difficulty is a bit harder here. So let's start. Refer to the insert for the list of pseudocode functions and operators. Complete the pseudocode expression so that they evaluate to the value shown. Any function and operator used must be defined in the insert. So let's open the insert at first. So you are given this insert where you will be given a list of functions, right? So we will be using this insert to answer the questions. So let's see what we got. We have something that is enclosed with C. The C is being sent as parameter and we add this with something, right? So let's see. We notice the value of 69. It is kind of close to, I guess, 65, which is the ASCII value of A. So we might want to use that function. So we have ASC here, ASCII. So let's try this. We write ASC here, ASCII. All right, so we have ASC here. Now this will return an integer value. For example, ASCII A returns 65, ASCII B returns 66. So ASCII C will return 67. So we add 2 to the value, right? So we just add 2 and we get the answer of 69. Then 9 dash string to num4. So we are converting this to num and we are going to run an operation here. So let's see the operations that we can run. We have these operators, right? So we can addition, multiplication, division, subtraction doesn't work, doesn't result to 1. So let's try this. We can use mod. 10 mod 3 evaluates to 1. So 9 mod 4 will evaluate to 1, right? Because the remainder is 1 when we divide this. Next question. We have to do an operation that converts to 6, right? So any valid operation works. For example, we can convert this to integer. We are running an operation and we are converting this an integer. So that's right in here. And here we are going to divide. So 25 divided by 4 is going to be 6, right? 6 point something. And if we convert this in integer, the decimal point gets away. Then we have fast and dash papers. So you will notice there are two brackets here, right? That means there will be two functions that will be used. And here is two blanks and this paper. So this is a concatenation. We are going to extract the word papers and we are going to convert this into lowercase, right? So let's see what we have. So here we have two lower. We can use this and we can use the mid function. So let's try this. So 2 lower, then we have mid. And all right, so we have a function like this question had a bit of less space, that's why a lot of you got confused, and since we are using two functions here, many of you got confused. So since we're taking mid, we only want this part. So p is the fifth character, so we can write a 5 here, and the length of the word papers is 6 characters, so we will take 6 characters from here. Evaluate the expressions given in the following table. The variables have been assigned values as follows. So we have shield active and combo active. All right. The shield active is false. This part is false. This part is false, right? This part shield active is false. Then we have combo active. So we have AND operator. So one of the operator being false means this will be false. Let's write false here. Next, armor intact. This is false. Then we have or not shield active. Shield active is false, so not shield active. This part will evaluate to true. So this is true. Alright, next up we have not combo active or shield active and not armor active. So let's evaluate this part by shield active is going to be set to true, false, and not armor intact. Armor intact is alright. So we have an AND operator. So any operator, the next part doesn't matter actually. This part doesn't matter. Since we have a false here, this whole part will be false. So we have not combo active. Combo active is true. So not combo active is false. False or false is going to evaluate to false. Now, not shield active or armor intact and not combo active. Combo active was true initially. So now not combo active. This part will evaluate to false. That means the whole part will become false. Next part. The following pseudocode assigns a value to an element of an array. So we are given 2D array, but we notice that there are 3 variables given here, right? So this cannot be a 2D array. Only the name of the array is 2D array. So it is written to confuse you guys. Complete the following table by writing the answer for each row. The number of dimensions of 2D array. So we have the dimension of 3. Then next question. The technical terms for the minimum and maximum values that the variable q may take. So the variable q may have a lower bound and an upper bound. Lower bound is the minimum term and upper bound is the maximum term. This represents the index. Technical term for the variable p in the pseudocode statement. So p is the index. We can use index. This is for second dimension. It's okay if you mention it or if you don't mention it. Dimensions part. Or this can also be called subscript. The following information must be recorded for every player in a team. Player name, which is a name, and number of runs scored, an integer. State a suitable data structure and justify your answer. Alright, so one method is record, right? We are going to store the player name and the number of runs in one record. Justification is this will allow different data types to be stored under one identifier. You can also use two 1D arrays. So the way this works is one 1D array will represent the string. This 1D array represents the string which contains the names, and one 1D array represents the runs, right? So runs. So this can also be done. Next question. 4 program modules form part of for a football team auction. A description of the relationship between the modules is summarized as follows. Draw a structure chart to show the relationship between the 4 modules and the parameter passed between them. So let's see. Update rate calls either extend contract or release player. So this is calling extend contract or release player. So this is the main part. Now, check interest. Call with player ID returns true if another team player has shown interest in the player, otherwise false. Alright. Then we have extend contract call with parameters player ID and team ID. And this calls check interest, right? So that means update trade will be the main parameter. So we have update trade here. So we have update trade here. Then we have extend contract and under that and release player. Alright. So if this is extend contract, check interest will be under extend contract, right? So let's draw it here. Alright. So now we have some functions. Update trade, right? We are going to write the module name here. this is update trade, and let's write extend contract. This is going to be here. We have release player, and we have check interest. All right, then this is going to be joined, right? Update trade is going to be joined with this, release player will be joined with this, then update trade extend contract will be joined with check interest. All right, now for the next part, we need to run individual functions, right? Extend contract called with parameters player id and team id. So we are going to draw here player id and team id. This is one and this is one. All right, so one of them will be player id, one of them will be player id, and the other will be team id. Next up, extend contract returns true if the contract has been successfully extended, otherwise return false. This is a flag variable. That means we should return a boolean. This will be filled like this. Now cause check interest to see whether another team is interested in the player. So since we are checking if the another team is interested in player, so that means this will be called with player id, right? And check interest returns true or false. So that means a flag variable is being returned. So we are going to return a flag variable, boolean variable like this, and we are going to take input of player id. Now we have release player called with parameters player id and team id. So we are going to call with player id, we are going to call with team id. Player id, then we have team id here. Then returns a real value representing the player's buyout fee or auction price. So we just return a real value. Now we need to update the symbol here. So here update trade calls either extend contract or release player. That means this is a boolean operation, right? So we are going to have a diamond or rhombus shape here. A shape like this. All right. So next question. The definition for the module release player is amended as follows. Call with parameter player id, team id, and buyout fee. The module checks whether player is being released before the contract and then assigns a new value to buyout fee. Player id and team id are of type string, buyout fee is of type real. Write the pseudocode header for the amended module release players. All right, then you will notice one thing, that this variable is being assigned a value. This variable actually exists outside the function, but we are assigning a new value inside the function, right? This means we will pass this by reference, and this to player id and team id will be passed by value. So let's write it down. We have procedure release player id. We do not need to write pass by id, sorry, pass by value, because it is already being done by default. We have string here, then we have by ref, buyout fee is of type real, something like this, and this is not going to return anything. A program will take purchase amount as input, checks if the purchase amount is greater than 1000. If yes, set the discount rate to 10%. Otherwise, check if the purchase amount is greater than 500. If yes, set the discount rate to 5%. If neither condition is met, set the discount rate to 0%. So we are going to check three conditions here, right? Then calculate the final amount to be paid by multiplying the purchase amount by 1 minus discount. Output the final amount to be paid. Draw a program flowchart to represent the algorithm. Variable declaration are not required. So now let's try to draw the flowchart. So starting off, we have a start statement by default. So this is a start statement, and we end this using an end statement. So everything we do must lead to the end statement. Now take the purchase amount as input. So let's just take an input. Input purchase. Then check if the purchase amount is greater than 1000. If yes, we go to one branch. If no, we go to another branch. Now let's write a condition is purchase greater than 1000. So if this is yes, we run this line. And if this is no, we go to the next part. All right, if yes, set the discount rate to 10%. So let's just set the discount rate to 10%. Set let's draw a rectangle here. So this is going to be 10%. Then if otherwise, check if the purchase amount is greater than 500. So we have to repeat this part. Is purchase amount greater than 500? Now we are going to have two branches. One is for yes and the other is for no. Now let's draw the shape again. So if the purchase is not greater than 500, we set the discount rate to 0. Else, we set the discount rate to 5%. Alright, so I have drawn out the final graph, final flowchart. So we have set discount to 0 when purchase is not greater than 500, else we set the discount to 0.05, and at first we check the condition of is purchase greater than 1000, right? So everything will lead up to this, meaning these statements, right, checking this is done, and after all of this statement will always run, right? So everything will lead up to this, and here we set the paid to purchase into 1 minus discounted, then we output the value of paid. So here output the final amount to be paid, then we go to the end statement. All right, next question. An algorithm is represented by a state transition diagram. The table shows the input, outputs, and states for the algorithm. Complete the state transition diagram to represent the information given in the table. So we are given with a table like this. All right, so at first we should notice how many states there are: s1, 2, 3, 4, 5, right? So let's draw. We have s1, we have s2, so we need 3 more. So let's draw some circles here. 1, this is going to be one state, this is going to be another state, and let's draw another state here. All right, now let's draw it. Now we are going to evaluate this line by line. So here the current state is s1, we take an input of 0 and the output of 1, so this part. Then we go to the s2, so this should be s2. This should be s2. All right, now this part is done. S2 we take an input of 0 and output of 1, so this should lead to S2. That means it will be a self loop, something like this. And we take an input of 0, output of 1. All right, next up we have S2 input of 1 and output of 0. So we have S2 input of 1 and output of 0, and this is going to lead to S5. So let's take an input of 1, output of 0, and this should lead to S5. So we are done with this part. Now going to the next statement. So next up we are going to do this row. So from S2, if the input is 2 and the output is 1, we go to S4. This is a new state, right? So let's write a new state here. S4, let's name this S4. This is a new state. So from S2, if the input is 2, the output is going to be 1. This is a new state. This is done. Now from S5, if I give 0, the output will be none, and we will stay in S5. So this has only input, no output, right? So we are going to write the input only here. Now from S5, if I give 1, the output will be 0, and we go to S3. So this is a new state. So let's name this state S3. The input is 1 and the output is 0. So from here we have a arrow from S5 to S3. The input is going to be 1 and the output is going to be 0. This is done. From S4, if I give 0, the output is going to be none, and we stay in S4. So here we will have a self loop. From S3, if the input is 0, the output will be 1, and we will stay in S3. So this is also a self loop. So this will be 0 and 1. So this is the state transition diagram. Alright, next question. A program is created to process an array of integers. The integers are stored in an array numbers. The first n elements are to be processed. The pseudocode for this program is shown below. So you are given with a pseudocode and you have to draw the trace table. For I, so let's keep this for a bit. Trace the execution of the pseudocode for the value n is equals to 5 and the given array of integers. So you are given n and this is the array, numbers is the array, and there is some integer stored here. So let's try this. Now for I 1 to n, for I 1 to n, so we are going to set I to 1 at first, and this will loop till n minus 1. N minus 1 is now 4, right? So we will be looping from 1 to 4. J will be set to 1, so we will write a 1 here. Repeat until this statement is made. Alright, so this end if is actually should be under this. Alright, so end if should be here actually. So let's see. Repeat if number j is greater than number j plus 1. So the current value of j is 1, the current j plus 1 will be the next number, right? So if this is true, meaning this number is greater than this number, then only we will switch this, right? So we are not going to perform any operation now because 67 is already higher than 1 3, right? So let's keep this. Now we are going to increment j will become 2. Now we will check this again. If number j is greater than number j plus 1, number j is 67, and is this greater than number j plus 1, this is greater than 45, and this is true, right? So we will set 45 here, and 67 will be set here. All right, so the temporary value of a should be what? Number j at first, which is 67. Now we are going to increment j will become 3 now. Again we check if number j is greater than number j plus 1. So this is j now, 3, right? So is this greater than 4? This is true. 67 is greater than 22, right? So we are at first going to set a to number j, which is 67. Now number j will be number j plus 1, meaning this will become 2. Number j plus 1 will be set to a. This means this will become 67, the value written here, and then end if j equals to j plus 1. So this becomes 4 now. Now we are going to check again. This 4 is greater, this number and this number will be compared. 67 is greater than 3. That means I will store 67 inside a again. 67, and I'm going to store a 3 here and then 67 here. Alright, j will become j plus 1. This will become 5. Now repeat. So j is now 5. N minus 1 plus 1. This means n is 5. 5 minus 1 is 4. 4 plus 1 is 5. So this is equal. J is equals to this part, right? So that means the loop will end and we will go to the outer loop again. So I becomes 2 now. And j will be set to 1. Alright. So let's see. Repeat until j is equals to n minus I plus 1. Alright. So now we compare number j with j plus 1, meaning we are going to compare the first two. Alright, 13 and 45. So nothing will happen. This will be incremented, this will become 2. Now we are going to compare 45 and 2, right? So 45 is bigger than 2. That means a will be set to 45 at first, then 2 will be set to here, and 45 will be set to here. J will be incremented, j will become j plus 1. Alright, and until n minus I plus 1. N is 5, right? 5 minus I is 3. 3 plus 1 is 4. So this condition is taking 4 for now. Alright. So for number 3, we are going to check 45 and 3. So 45 is greater than 3, right? So 45 is going to be stored here at first. 3 is going to be stored here. Then 45 is going to be stored here. Alright. Then j is equals to j plus 1. So this will become 4. Now this condition is met, right? So we are not going to perform this inner loop again. So let's go to the next now part. I is going to be incremented. This will become 3. Now I will start with j equals to 1. I'm going to compare 13 and 2, right? So 13 is bigger, so 13 will be set to here. Alright, 2 will be set to here and 13 will be set to this value. Now I go to the next value, 2. So here 13 and 3 is compared. Of course 13 is bigger, so I'm going to set 13 to here. 3 will be set to here and 13 will be set here. Now I will increment again, this becomes 3. and this is the end of the loop actually. Now going to 4, line number 4, j will be set to 1. We are going to compare 2 and 3. So 2 is smaller than 3, so nothing will happen. Increment it, and now this loop will end because this condition until j is equals to n minus I plus 1 is met, because n is 5, I is now 3, I is now 4, 5 minus 4 is 1, 1 plus 1 is 2, so only 2 times it will run. All right, so the final values are 2, 3, 13, 45, and 67. Now state the purpose of this algorithm. So we sorted this array serially, right? So we are going to write this in words: to sort in ascending order of items. Describe what evidence from the test result suggests that the given pseudocode is inefficient. So here we ran the code for 4 times, but in the fourth loop nothing happened, right? No swaps were made, so that makes it inefficient. All right, the diagram represents a service queue, abstract data type in a government office. So this is a queue which is represented using an abstract data type. The organization of this queue may be summarized as follows: the next person points to the person who will be served next. So this person will be served next. This is in front of the queue. The last added person points to the person who was most recently added to the queue. So this is the last person. This is back of the queue. The queue is implemented using 3 variables and a 1D array of 8 elements as shown. The variable num_people stores the number of people currently in the queue. The pointer variables store index number of the array. Complete the diagram to represent the state of the queue as shown above. So here these people will be stored in a serial order, right? It doesn't actually matter where you store, but they should be contiguous to one another. So you should store this serially. All right. If the value of next person, last added person matches with this, then it is okay. All right. So let's just follow this to make it easy. P3 will be set here. Then we have P4, P1, P2, P5, right? All right, so this is the next person. So next person is pointing to 2. The next person will point to 2. This is the last added person, right? 5. So this will be set to 6. And the number of people is this number, right? 5 people were added. Next question. The module add to queue will add a person to the queue by manipulating the array and variables in part A. The queue implementation is circular. When pointers reach the end of the array, they will wrap around to the beginning. Before a person can be added, it is necessary to check if the queue is not full. The algorithm to add a value to the queue is expressed in 6 steps. Complete the algorithm steps. Alright. So if num_people is dash, then jump to step 3, meaning we are going to stop. So we only stop when the queue is full, right? So if num_people equals to 8, then we jump to line step 6. Increment something. So we should increment last added person, right? So 6 should become 7. We are going to add a person here. If dash, then set last added person to dash. So this is a circular queue, right? So if the last added person becomes from 8 to 9, we are going to go to 1 again, right? So here we're going to write that. All right. Then increment dash. So the number of people will increase by 1, right? So we are going to increment num people here. Set the dash at the index stored in dash to the dash being added. So set the dash. So this should be the element, right? Set the element at the index stored in dash to the dash being added. So here we have a variable named what? Last added person. Need to manipulate that. Set the element at the index stored in dash to the dash being added. So here the added thing is might be person, right? A person or the element or something, and this at the index stored in dash, this will be the end of the last added person, right? So we're going to write this here. All right, next question. A programming language has string functions equivalent to those given in the insert. The language includes a left and right function, but it does not have a mid function. Write the pseudocode for an algorithm to implement your own version of the mid function, which will operate in the same way as shown in the insert. Do not use mid function given in the insert, but you may use any other function. Assume that the value passed to the function will be correct. So here, let's see what mid does. Returns a string of length by starting at position x from this string. So here we are going to start from 2 and return 3 characters, right? So you have to define mid at first. So let's try this. This is a question from the past paper. Actually, it is not modified. The question is exactly same as it was in the past paper, but this question was a bit hard, very hard in fact, because many candidates were not able to solve this in the real exam either. So function mid, here we have three parameters, this string, and so let's just copy it as it is. All right, function mid. All right, so we have this string x y. So let's see how this thing actually works. All right, so let's say I have a random value a b c d e. If I give mid 2 3 and the variable, then we are starting from 2 and going 3 characters, right? So the way you can solve this is you take 4 characters at first from the left part, then from the right part you take 3 characters, right? So this is left and this is right. So the way you calculate this, b is being set to what? X. So if we have a b c d e, b is going to be the value of x, right? So we are going to take left, this is y, right? So we are going to, if we have an input of 2 and 3, we are going to take 4 characters from the left, right? So we basically do something like this. We have x plus y, the number of characters y, so we get a value of 5, right? We separate this with 1, so we get a value of 4, meaning we are taking 4 characters from the left part, right? So let's do that. So let's keep one line blank for the declaration. Mid str, mid string will be set to left. The input is this string, then we take how many characters? X plus y minus 1, x plus y minus 1, this number of characters, right? Let's just erase this bit. All right, next up, we are now going to take y number of characters from the right. We already have extracted the left part of the array, left part of the string, so we take the right part. We already have a b c d, right? We are going to take 3 characters from the right, which is the value of the y. So again, now write mid str right. Now we are going to take from mid string, we are not going to take from the main string again. So here we take y, and since we have a function, we need to give a return. So we will return mid str. Since this is a function, we need to give the end statement end function. Alright, we used only one variable here, so let's declare that. Declare mid str as string. Alright, so this is the answer for this question. This question is actually not that hard, it's just that the pattern of this question is very different from the other questions. So candidates usually face a lot of problems while solving this. Now the final question. This is a pretty big question, so let's try it. I'm going to explain the code and my thought process at first. Nehal is designing a program to manage registration for Fastpaper Mock Championship. Student registration are submitted as text files, which are known as registration files. So there is a file structure. Line number 1 represents the name, line number 2 represents phone number, line number 3 represents candidate number, and line number 4 onwards represents subject. Each subject is listed on a separate line for the remaining lines, maximum of 8 subjects per student. The program uses the following global arrays, no declaration needed. Candidate number stores the candidate numbers for each student, name stores student names, phone stores student phone numbers, subjects are 2D arrays storing up to 8 subject, 8 column per student, password stores randomly generated 4-character password for students to access results. Additional variables, declaration is not needed. Alright, you have to be careful, you don't need to declare this. Register students stores the number of students currently registered for max students. Registered max students stores maximum number of students, length of the above arrays. So we have a maximum number of students that we can store in the system, which is represented by max students, and registered students represents number of students who are currently registered. The programmer has started to define program modules as follows. So let's read the modules. Add student data, takes a registration file as parameter, reads the files and stores the student's information into the appropriate arrays. Generates a 4-character random password using random character. Adds the password to passwords register student. Updates register students. Sort candidate sorts out all the arrays in ascending the order of candidate number. So we have some arrays here, right? These are global arrays. So these arrays all should be sorted, but it is sorted in ascending order of candidate number. So we are going to run a loop on candidate number, and using the index of candidate number, we are going to manipulate the other arrays. Maintains the corresponding data element between the arrays. Then we have random character. Generates a single random character from one of the following ranges. Every character will have the same probability: A to Z, A to Z, and 0 to 9. Returns the character can be called multiple times to create a 4-character password for a student and add it to passwords. For reference, relevant ASCII values are follows. So write a pseudocode for the module random character. You may wish to refer to the insert to build for built-in function. So we have a random character builder, right? So let's see if we have any random functions, which is this rand. We are going to use this function to execute this code. All right. So returns a real number in the range 0 to x, not inclusive of x. So for example, rand 87 could return 35.43. So we have a random number, we are going to convert this in integer. All right. So this question, a very similar question to this came in the past paper, where you basically have to use this solution. You have 3 ranges, right? We take a random number which ranges from 0 to 2. And if the value is 0, we map to this. If the value is 1, we take another random number for this. And if the value is 2, we take another random number for this. But here you are asked to use same probability for every single characters, right? A to Z, meaning we need to generate a random number depending on the number of characters. So A to Z, the range is what? 26. Here the range is 26. Here the range is 10. If we add all of this becomes 40, 52, 62. So we are going to generate a number from 0 to 62, from 1 to 62. All right. So let's start the code. So the main idea is we are going to generate a random number from 1 to 62, and if the number is from 1 to 26, we are going to map to this. If the number is from 27 to 52, because 27 plus 26 is 52, then we are going to map to this. If the number is from 53 to 62, we are going to map to this. All right, so this is the main notation. Now let me show you the code that I wrote. All right, guys, so here is the function. So function random character returns character, so there is no parameter given in this function, so we are going to keep this blank and we are going to return a character. So we are going to declare every variable that we are going to use. Then there is 62 possible characters, right? So we are going to create a range from 1 to 62. So for 62 possible characters, random number 62 returns a random number from 0 to 62 exclusive. So we are going to convert this to integer and we are going to add 1. So the range becomes from 0 to 62, 0 to 61 to 1 to 62. Now if this range is less than or equal to 26, that means this is going to be a character from A to Z, small letters. Else, if the index is less than or equals to 52, meaning this range, then I will set a character from capital A to capital Z. Alright. Now, if else, I will map 53 to 62 to 0 to 9. So this range. This character will be converted to character and we are going to add 4 to the index. Right? Because we need to map what? From 53 we need to map to 57 because in the range. So here you need to map 53 to 62 to 0 to 9. So the range from 0 to 9 is from 48 to 57. So the range is 4 off, meaning we are going to subtract 4, subtract 5, right? So this is going to be minus 5. So we get a range from 57. All right, so let's go to the one next question. As a reminder, the module description of add student data is repeated. So we take a registration file as a parameter. So we take the file name as a parameter, reads the file and stores the student's information into the appropriate arrays, generate four character random password using random character, adds the password to passwords with register, and then update registered students. So using this function add student data, we are going to add data to the arrays, right? So this is a procedure because it returns nothing, it just updates it. All right, so let's start. So procedure add student data, we take file name as a parameter of string, then we keep some line gaps for declaration, then we open file name for it, this is the file name, right? Then we read one line from the file and store this in the names array, and the position of the array will be registered student. Alright, then we read another line and store it in phone number, and we take another line and store this in candidate number. Now read subject up to 8. So we can take up to 8 subjects. So we are going to keep a count to keep track of the number of subjects. So why not end of file name? So this is a file name and we are checking if the end of the file is not reached and the subject count is less than 8, meaning the student still took less than 8 subjects. Alright, so then we read file and store it in a variable called line. Alright, then I'm going to set the value of subjects registered student subject count to line, meaning we are changing the value of the current student. Alright, current student subject to the line that we just got, and we increase the subject count by 1. So we are going to basically create a 2D array, right? So if you see the diagram, so here what's happening is we have a variable named subjects. So here we have variable named subjects, right? This is a 2D array. So let's say subjects. Here I have one student number and I'm going to register one subject. Alright. So after that the subject count is incremented by 1. So this is our new subject count, right? So this is incremented by 1 and we store new subjects. We can store up to 8 subjects in this array. Alright. For the next element we use another row to store the other subjects. Alright. And well. So password of registered students is equals to random character plus random char plus random character plus random character. So we are going to take four random characters and insert it in password. Now register student will be incremented because we just completed registration for one student, and at the end we close the file. Alright, now next question. So as a reminder, the module description for sort candidates is repeated. Sort candidates sorts all the arrays, candidate number, names, phone number, subjects, password in ascending order of candidate number. Main is the corresponding data element between the arrays. So the question asks for something like this. Let's say I have candidate number like this. I have candidate 5, 2, 3. Alright. And then I have names. John, Paul, Jake. Alright. So whenever we bring this to the top, Paul has to move to the top too. Whenever we are sorting. Alright. So this is basically sorting all the arrays. So let's write the efficient pseudocode algorithm. So here is the example of pseudocode algorithm. Procedure sort candidates. This is a bubble sort. So and it needs to be efficient. Now boundary is equals to registered student minus 1. Now repeat no swap. So these bubble sort won't run when there has been no swap which is made, right? So no swap is equals to true. For I 1 to boundary minus 1, so we are going to decrease the boundary by after every iteration. For if candidate number of I is greater than candidate of I plus 1, meaning the candidate previously. Let's say I have two candidates here. Candidates stored in the previous part, let's say 147, 26. So if this is true that the previous candidate is higher than the next candidate, we are going to flip this two using this code. Alright. Then I am going to swap names in the same way, but instead we use the names array. Swap phone will be done in the same way. Then swap subjects. For swap subject, you have to perform an array operation, meaning you can't just replace one array with another, right? This is a 2D array, so you can't replace one element with other element. You have to change the value manually. For example, here call 0 to 7. So we had 0 to 7 columns, right? So here were there some values, here were there some values. So we are going to set temp to subject and we are going to change the value of the subject. We are going to switch the subjects. Alright, here we are performing the switching operation for the subjects and we store it in the temp. Now coming to swap password, we set a temporary variable called password and we again use the password and switch it. No sir. Until and next boundary will be boundary minus 1 because whenever you are done with sorting, let's say A, B, C, D, whenever you are done with sorting, the last character is always the biggest, right? The loop ends when until no swap is equals to true. So this should be true strictly. Alright, next question. The random character is modified so the alphabetic characters are generated twice or more often as numeric character. Describe how this might be solved. So the probability will increase for the alphabetic character, right? So here it needs to be twice as often. That means the probability of alphabetic character will be more. So the answer could be generate random int divisible by 3. Split into 3 ranges where alpha Alright, this is the answer. So we are done with this paper. So if you guys had any question, you can ask me, you can reach out, and good luck for your final exam. I hope it goes well. Thank you.